frustrating is it that whenever you reach for a knife these days, they're always made out of metal. I know, right? Believe you me, you're preaching to the... Some of you might be thinking, hey, old Tony, slow down. I got a plastic knife, or maybe even a fancy ceramic one. Oh, look at me. Sure, I'll give you that. But how much cooler would a knife be if it were made out of thin air? Well, have I got something for you. This is an air knife. Look familiar? You may have spotted this in a recent video. You might have even thought I made this up. But I assure you, this is a very real thing you can buy right now, and not just some fancy party trick for getting into women's boxes. That said, I may have stretched the truth just a little, a smidge. This will not, in fact, cut open a cardboard box. Well, I mean, maybe if it was thin cardboard, very thin, wet cardboard, maybe. This unassuming little thing, however, turns ferocious, unbridled compressed air from your compressor of all places into a very thin curtain of laminar air. It's basically an air nozzle, you know, like one of these for blowing air on stuff, but I think it's a lot cooler. You know, the air knife bit is probably just marketing doing what marketing does. Otherwise, would you watch a video about a laminar flow air curtain maker? Okay, fine. So would I. Turns out it's hard for me to show you what this thing is doing. I apologize that the air I happen to be using is invisible. But I'm sure we've all used those blade hand dryers, like the air hand dryers in bathrooms, right? First couple of times you put your hands in there, you know, it was new, it felt really cool, but now they squeeze you out. It feels exactly like one of those. There's like a line of compressed air blowing across my body. I mean hands, definitely hands. So no, Dyson didn't invent the air knife. At least I don't think he did. I didn't actually look that up, but these have been around a lot longer than the skeezy hand dryers. These are used in manufacturing and process control in a million different things, but mainly 3 or 4. They dry stuff, of course. Imagine you have a big conveyor belt of wet or oily thingamajigs. An air knife or 15 along the way dry all of the product off. They clean parts, blowing away debris out of, I don't know, machine or molded parts, PCBs. They probably don't use these in flour mills, I imagine, but you get the idea. They're also used for cooling, of course. I've even seen them used as literal air curtains that divide rooms. There's like a super fun wall of air when you enter and exit. Some versions of these even have like magic ionizers built in. They blast away static electricity from sheet stock, you know, like potato chip bags, that sort of thing. Before these came along, most folks used flat air nozzles, or just a lot of regular air nozzles, or heck, even a pipe full of holes. And I'll be honest with you here, there are still a lot of flat nozzles out there, and pipes with holes. Don't be calling me out in the comments, telling me where you work it's all flat nozzles, because I wouldn't be surprised. The big advantage of these though, over nozzles, or pipes with holes in them, is that they use a lot less air. It might sound weird, but air is silly expensive. I have personally worked on entire one-man teams assigned solely to finding and fixing air leaks. Despite what you might have just heard a few moments ago, air nozzles also make a lot less noise for the same amount of drying or cleaning a comparable flat nozzle does. If you're still using a flat nozzle in the middle of the office drying your whiteout, do everyone a favor and try an air knife. Thank me later. On the flip side, generally speaking, air nozzles can generate a lot more force than air knives, so there are some trade-offs. I could go on about these things forever, but the reason I gathered you all here today is I want to try to make my own. One thing I've always noticed, air knives all tend to be straight, like just a stick of air knife. 1, 2, 5 feet long, but always straight. Would this work if we bent it around on itself? Could we make an air donut? And what would it do? Now hold on, before you unsubscribe, yes, ring blades are a thing. Sometimes called ring wipes, I think. And yes, they sure look like round air knives, don't they? These are used for drying or cleaning round stuff instead of flat stuff. Pipe, tube, cables, tapeworms, that sort of thing. But ring wipes send the air in radially, or, you know, maybe kicked back just a little. So it's impinging on the round thing you're running through it. What I'm talking about is bending the air back in on itself, sending it back down like axially, like a jet engine or a toilet. I suppose we should talk about what this regular air knife is doing before I start making life complicated. This is an X-Air made in good old Cincinnati. Fundamentally, it's two flat pieces of metal, sort of flat, some features in there. Air comes in the back and is channeled out of a very small slot on the front side instead of out of a hole like a nozzle, like your blowgun. I think this slot should be on the order of magnitude of, 2/3 thousandths of an inch. Let's start with 2. Maybe a little bigger than 2. 2.5. Help if I just used one shim. Yeah, I guess about 2.5. 2 to 2.5. That's 0.05 millimeters. I used to think these were crazy high tolerance machined parts, and that's what made them so expensive. However, people are smart, usually. There is no super flat 2.5 thou machined gap. Instead, there's some sort of piece of shim stock in here between the two flat parts that sets that gap. That's way easier to make. And if you keep the price high, well, everybody wins. Actually, let's try to take this apart. I kind of rather wouldn't, but I'm planning to borrow some dimensions. Oh, there it is. Oh, wild, a plastic shim. I want to be very careful with this thing. Let's see. So air comes in the inlet here and fills sort of this plenum. See that milled slot in there? We've got this shim on here that seals up the back and only lets air out over this small land here, right? The cap is on there like this. I'll just offset it. The shim seals back here, keeps the cap lifted about 2.5 thou, 2 thou, whatever that was that we measured. Only place the air can get out is between those duct lips created by the cap and the body. When that very fast sheet of air comes flying out, it's riding along just one wall. And does anybody here remember the Pina Colada effect? Maybe an end view would be a little more helpful. We've got the air coming in opposite this. That's just a cap, a plug. Air's coming in this side, fills up the body here, and the only way out is through this long, thin gap at the top. Now, on its own, it would want to just shoot straight out. But because we've got a wall on one side, we've got that Coanda effect thing going on. Low pressure on one side, ambient on the other, it bends that jet down and it follows the wall. So the air sheet coming out of this air knife is pointing straight down, and it's entraining all of the air in the room or around it and pulling it along. That entrainment gives it kind of like an amplifying effect. It's sort of blowing more air on your stuff than you're pumping into the back. That entrainment over this wide area is what makes these more efficient than just a free jet, just a nozzle in open air. The bend, on the other hand, does a couple of things. I think, I'm no air scientist here, keeps the flow laminar for longer compared to just firing one of these into free air, consequently keeping the flow of air quieter and more directed. This knife here, I'm just guessing, probably keeps the flow laminar out to, 8, 10, 12 inches away. That's pretty impressive. But that brings us back full circle. And by full circle, I mean I want to try to make a circular air nozzle with the same discharge geometry. Can't believe I don't have anything round here. Imagine an air knife that looks like this, kind of like the ring wipe. But unlike the ring wipe, I don't want the air to kind of come in radially to wipe the cable. I want it to go straight out axially, like a jet engine. And we'll see what it does, if it does anything at all, except make noise and waste air. Baby, if you've ever wondered whatever became of me. I'm making air knives in Cincinnati. Cincinnati. E-X-A-I-R. I thought this was going to be mostly a lathe project, but turns out I don't have any 4-inch round stock. Also, I pulled a fast one on you. I was so hung up on finding a 4-inch cutoff, I completely forgot about the thickness. I started off with this. I cut this off and didn't realize how thick it was until I got to the mill. I only really need about 3/4 of an inch. Yes, I could have just sanded this to size with some 400 grit sandpaper, but I just dug up a thinner cutoff. Fine print paragraph 2, none of my big drills fit in the mill. I've always meant to get tooling that uses some of my drill tapers, but I don't have any. Yes, I could have just put the hole in this with an end mill, but remember, aside from a karate chop or maybe a saw, the fastest way to get material out of something is a drill. Now I'm going to mill in the ring that becomes the air plenum, the air cavity, which I also could have done on the lathe, but there, to cut a groove into the face, you'd need a, can anybody guess? That's right, a face grooving tool. And, well, it's just easier here. Not to mention, even though I just mentioned it, I'm going to need a bolt hole pattern around these features, which, historically, has always been challenging for me on the lathe. I know I tend to do a lot of tight shots on this channel. I don't usually work on big stuff, and I want you to see what I'm doing. But for kicks, here's what this looks like from a few steps back. This Maho milling machine doesn't have the largest capacity or the mostest horsepower, but sure does take up a lot of space. For scale, here is one 100% totally human earth hand. The bolt hole pattern went fine. Not a lot of surprises here. These are number 19 drill holes, somewhere around 4 millimeter. I plan to tap these M5. You would be shocked at how many M5 screws I have left over from the CNC router build. Anybody remember that? To play it safe, I counterbored them. Just cut a little recess at the top so I have some clearance and my threads won't come all the way up to sort of the top surface. I wouldn't want to lift any material when I'm tightening screws that could interfere with the seal on the surface. I know you're wondering, and the answer is yes to both your questions. I probably did add too many holes and now I'm paying the price. And yes, I'm living quite dangerously here. That's a tap chuck in a 3/8 adapter in my M12 drill. Well, then there's the parts. Dare I say they even look respectable, well, at least believable, you know, for some guy messing around in his garage. Did I show you the cap part? I may have not shown you the cap part. Same exact operations, except here we've got clearance holes and counterbores. Screws drop in here, etc. But now comes the hard part. I need to flatten out the mating surfaces and sort of blend in a nice small radius that rounds its way down into the bore. Can you even see what's going on in there? It's a high-speed steel forming tool. Hopefully it won't shatter and get us a nice radius. I know you're scared. I'm scared too, but together. I think I need my magnifiers. I can't totally see where the material's coming off. I mean, I've got a good guess. Holy smokes. Are you kidding me? I don't think this tool is wrapping around enough. There we go. My dog doesn't like that much either. I think that's pretty darn close though. I bet we could blend that out with some paper. That top doesn't, I mean, it feels right. I didn't sand out to the side, so maybe it's just that like color break, like from sanded to turned, but yeah, I'm gonna call that good. Onto the cap. And that's the cap. Not much happened here. It was just a bit tricky to face in the 4-jaw chuck since this part is thinner than like the steps and the jaws. No big deal, just tedious, but that's why they pay us hobby machinists the big bucks, right? I didn't go quite deep enough to like 100% clean the corrosion off. Remember how gnarly this part looked? This unfortunately is the sealing side too, but I don't know. Seems good enough to me. On the base, I did add a port for compressed air. It's just a 1/4-inch hole. It's smaller than the port in the factory knife. If this doesn't work or doesn't work well, I may try to open that up. I'm not sure how much air something of this size is going to need. I also tapped it, of course, so we can screw in our fitting. Finally, we're going to need a shim, like a gasket, something to set that gap. I printed a template. I was going to use this to make the shim, but now I got to wondering if we couldn't just use the paper itself. Like that. This was about 2/1000ths. Depending on how much I sort of squeeze with the calipers, I'm measuring 3 to 4/1000ths on the paper. Then we probably should, if not account for, at least mention the inkjet printing, which adds probably another 40 millionths to the thickness. If you plan on working in a machine shop, by law, at least 1 in 5 of you will have to be the pedantic one. So get your practice in when you can. Since there's no kill like overkill, I'm going to torque all these down to the same 30 inch-pounds. Since this is a paper gasket, if I just ran these in with like a little impact gun, well, I don't know. I want to try my best to get a consistent gap all the way around here between the 2 plates. Now, I forgot where I left off. I'm going to be so sad if this doesn't work. Holy smoke! I feel a jet of air, like a ring of air. How the heck am I gonna, hold on a minute, how on earth? I gotta figure something out here. Wait, this goes, I should have put a valve on the end. Oh, I was hoping that it'd fall through there. Anyway. We're bending the air 90 degrees and up through that hole. Wonder how much. This is full, I don't know, 90, 95 PSI, 100, whatever it's. I am so going to regret doing this. Maybe we just start off with that much. I've been messing around with this thing on and off, mostly off, for the last couple of days. Honest to God, I forgot just how easy I am to entertain. In messing about, wow, look at that. You see that junk in there? I guess it's sawdust. I must have been getting some negative pressure in here. Huh. Anyway, in messing around, I added a second shim to the stack. I thought more air would be more better. Certainly, that is bulletproof logic if I've ever heard any. Turns out, very much not the case. With this larger gap, which is, I haven't actually measured this, probably around 7th thou. It's the same paper printouts. Yeah, pretty close, 7th thou, 6, 8-ish. Math adds up. Anyway, with the extra shim, my air donut just didn't work. All of the air immediately came out this side, like maybe around like 1/3 of the ring. I could feel like a C-shaped column of air. Sure, I guess in hindsight that might seem obvious. Big gap, air's coming in here, it's all gonna come out this side. But remember, it was only 7/1000ths of an inch. Yeah, I guess air will be air. I gotta blow this out with some. What's kind of wild is I didn't do the sawdust test with the double shims. This sawdust was from before with just 1 shim, so I guess sawdust is really thin. Anyway, we tried 1 shim, we tried 2. I mean, there's really no sense in stopping now. So I dug around and found this. This is 2/1000ths of an inch. So we're going closer to like the factory knife. This is just some Mylar, like plastic coated, whatever, metallized. That's 2/1000ths. I don't know if you can read that. Do you have any idea how many bags of chips I had to eat to find this? I had a little witness mark, so I'm putting this together the same way every time. I don't know if that matters, but... Give me just a second. I'm gonna head over to the vise and... Everybody hold on to your hats. That feels much tighter than before. I think it's making more force, or at least it feels harder to push this ping pong ball back out of the hole. That ought to do it. I don't know if I could really tell a difference there. Well, you can probably already tell just by looking, but I'm afraid I've got egg on my face. Allow me to explain. The 2/1000 shim works way better than the 4/1000. Don't know if you could tell over video. You might have to take my word for it, but the smaller shim has a much fuller, like cylindrical flow. Very well developed. Like it's a much cleaner cylinder. The inside feels more like hollow. I'm testing that by feel, sure, but there's definitely a difference. I think that means we're getting better laminar flow with that smaller shim. It's not breaking up or causing swirls or whatever might be happening. But that's not the important bit. My next step would be to drop down to an even thinner shim. I do have 1/1000 stock on hand. I mean, it's steel, but I bet it would work, or at least tell us if we're going in the right direction. But before going to all that trouble, I thought I'd try to do some homework, which I should have done before I even started this video. Now that we've made it this far to something that appears to work, I got to thinking there's probably some like math model that could tell us how to optimize this specific combination of air donut. Like for this hole diameter, this gap, this port size and airflow, the room temperature and humidity, phase of the moon, those must be all interrelated because of course they would be. And in 2 minutes of reading, guess what I found? That's right. I reinvented the wheel. I built an air amplifier. I had no idea these were a thing. Basically, we made a bladeless fan. Still pretty cool we managed to make one, but I don't know, that discovery just took a little bit of the wind out of my donut. I don't really have a way to measure the performance of this one, but get a load of this. 2-inch amplifier running at 90 psi is pushing almost 400 cubic feet per minute. If the spec sheet is to be believed, it's using about 16 cubic feet to put out 400 at the outlet. At 6 inches away, that goes up to 1,000 cubic feet. And fun fact, that's with a 3/1000 shim. I even found an adjustable one. You see that knurled lock ring? You loosen that, adjust the gap, no shims, pretty clever. Okay, fine, I guess it's not that clever, but it's cool nonetheless. I suppose that brings us to the end of our journey. Random places ending to stop a video. I'm still not sure why I'm so surprised this thing works. I don't know. Maybe it's good every now and again to reassure our dominance over the physical world around us. That, and I can finally cross air donut off my bucket list. Not quite sure what I'll use this for. If you have any ideas, leave a comment. I could use it to make airbender jokes. Or maybe even welding fume extraction. That could be fun. Or, you know, perhaps other stuff. Exploration, after all, is the spice of life. If you stuck around this long, I always enjoy your company and thanks for watching.